To my video. In this video I am going to explain you what is data warehouse implementation and data mining, that is module 2 of VTU syllabus in data mining and warehousing. Under this, today's topic is data and the types of data. Yes. So what is data? It is nothing but collection of data objects and their attributes. Yes. What are the objects? See, these are the objects for which we have its respective attributes. See, the attributes are for the transaction ID 1, 2, 3, 4 are nothing but the objects. For every object every object can be defined with respect to particular attribute called refund, marital status, taxable income, whether he is cheat or not. So with the help of these objects we can describe the object with respect to these attributes. So collection of data objects and their attributes is nothing but data. So an attribute is a property or characteristics of an object. So marital status is the characteristics of the transaction it is a customer whose number is 1, whose customer ID is 1. So it just gives the property or characteristics of that particular object called 1. His refund is done or not? Yes. So what is his taxable income? It is 125K. So examples of attributes are nothing but eye color of a person, temperature. If you take this table, the examples of attributes are nothing but refund, marital status, taxable income and cheat. Yes. Collection of attributes describes an object. As I said, all the attributes, every attribute describes the object. Next, size. Size is the number of objects. So what is the size of this data? It is nothing but 10. So how many? Because how many objects we have? 10 objects we have. And what is dimensionality? It is nothing but number of dimensions we have. So for describing the object, this object, how many number of dimensions is required? Refund 1, 2, 3 and 4. So the dimensionality is nothing but number of dimensions required to describe a particular object. So 4 is the dimensionality. Next comes types of attributes. If you take the types of attributes, there are two types. One is categorical and the second one is numeric. So if you take categoric, here it is it will define the properties with some description, yes or no, good or bad, or eye color is blue or black, like that. It will be having some description. It will not be having some continuous value. Okay, it has some discrete values. That is nothing but categorical. If you take height, tall or short, if you take the academic position of the academic status of the student, he is dull or strong or weak or excellent or medium or poor, like this we can rank without a numeric value. So these are all called, these values are finite and it cannot be infinite. Okay, 2 or 3 values, those are called categorical attributes. And under categorical attributes we can divide it into nominal as well as ordinal. Nominal is there is no order or no comparison, that is nominal. Whereas in ordinal, order will be there but it cannot be compared. See, if you take the student ID or USN, it will be in the order but we cannot compare the students with the USN number. Is it possible? One must be 18CS002, one must be 18CS003. We cannot say that whoever is having USN number greater value, he is great person. No. 2 and 3 are just his ID. We cannot describe anything out of that. So it is just order, but we cannot compare with this value. This is nothing but, these sort of values are nothing but ordinal values. Next category is numeric. So in this we have the data in numerical values like dates, temperature, time, length, value, count. Here again we have discrete and continuous value. Here in the discrete we will be having very finite number of values, whereas continuous it may be infinite values. So that is continuous. So special cases, binary attributes. Binary attribute is nothing but yes or no, or exist or not exist. These are called special attributes, that is binary. Only two values are possible in case of binary attributes, 0 or 1, yes or no. These are all binary attributes. Then types of data. So all till this we have seen what is data. Data is nothing but objects, collection of data objects and their attributes, and the types of attributes are categorical and numerical. Categories, that is categories of attributes. Here we are going to see the types of data. So we have 5 types of data. First is numeric data. Each object is a point in multidimensional space. So every object will be a point, is represented as a point in the multidimensional space. Then comes categorical data. Each object is a vector of categorical value. Then set data. Each object is a set of values with or without coins. For everything we will see with the example. Just read the definition now. Ordered sequence. Each object is an ordered sequence of, there will be some order. Now we will see in detail what is numeric record data. See, if data objects have the same fixed set of numeric attributes, then the data objects can be thought as a points in multidimensional space where each dimension represents a distinct attribute. So what we are doing here is, for every numeric data we are representing it as a point in the multidimensional space. Clear? Such data set can be represented by n by d data matrix. So how can we represent this? In the form of matrix with the n rows and d columns. So d is nothing but dimensions, how many number of dimensions we have. For every object, what are the values? That is represented in terms of rows. Next comes categorical data. As I said earlier, that just it will have some finite attributes, like finite values of a particular attribute, yes or no, single or married, high or medium or low. These sort of attributes or these sort of data are called categorical attributes. You take marital status, it can have only 2 values, either married or single. So it defines the category. So all the person who are, see, 1, 3 and 8 and 10, they all will come under the category called single. If you take 2, 4, then 6 and 9, they will come under the category called married. So what we are doing, we are categorizing, with the help of the attribute we are categorizing the data. So data that consists of collection of records, each of which consists of fixed set of categorical attributes. See the keyword here, fixed set. So we will be having only fixed set of categorical attributes. Only 3 we have for marital status. If you take refund, yes or no, that's it, just fixed set. And if you take cheat, yes or no. And if you take taxable income, high, medium, low, only 3 fixed set of categorical attributes we have. Then comes next type, document data. So each document becomes a term vector. So every document will be represented as a vector here. Each term is a component or attribute of the vector. So if you take a word called team, we will take this example. The team is the word which can be called as a component in the vector called document 1. Document 1 is nothing but a vector. So how many times this team has appeared, the word called team has appeared in the document 1. So how many times? It is 3 times. So this sort of data is nothing but document data. In every document, how many times a particular word have appeared. The value of each component is the number of times. See here, the corresponding term occurs in the document. So what is the use of doing like this? See, in Google, when we are browsing for a particular word, how it takes the data with the help of this data only. So wherever I find, say if I want to search something about data mining, it will take the data mining word, keyword, and it will search in all the documents in which it is present. So how many times it is present, so that it will assume that if the data mining is present in a particular document for more than 10 times, then it will categorize that data as a data mining relevant data. It will cluster it in the data mining subject, and whoever is asking for that particular data mining subject, it will be providing that particular web page. That is the use of this document data. Next comes transaction data. So the transaction data is nothing but which will give the transaction related data which is collected after every transaction. See, if you are going to supermarket and there we will be billing, whatever billed data will be collected, and that is called transaction data. Who came and what and all items he bought and what is the total amount, everything. So those sort of data is called transaction data. So each record is a set of items. A set of items can also be represented by as a binary vector, where each attribute is an item. Document can also be represented as a set of words. Yeah. Yes. Next is ordered data. If you take ordered data, it is used to represent, see here some order should be maintained. See GGTTCC, it means something. So this is the amino acid representation, genetic amino acid representation. So it should be in the order, we cannot change the order. So every order represents some information. So these are called long ordered. Since it is the same characters are repeated, they are of the data type long ordered string. It is mostly used in bioinformation. And if the same ordered data is in time series, see if I want to calculate the temperature of all the days from January to December, then see this is continuous data which should be in the order, right? This is the ordered data, but we have one more dimension called the time here. So with the time, if the data is ordered, then ordered data, it is called as ordered data with respect to the time. Next comes the last category, that is graph data. So what is graph data? See, web pages are coded are prepared with the HTML coding. Here every node represents a web page, and the linking, the edges represents the link between one document, one website to the other website. So what is this weight? The weight is nothing but how many times this document is linking this or referring this website. This is nothing but weight. So this is how I can represent the web page and the HTML links. So nodes are nothing but web document, and the edges, how many times this document refers or links the next document, this document or website. So this gives the relationship between the web pages, and how many times this web page is referring the other web page. So this is represented in terms of graph. I think you would have understood. Thank you for watching.